afternoon, ladies and gentlemen. Welcome here at the exhibition Hydrogen and Fuel Cells Europe. We are here at the Hanover Fairground in 2022. I welcome you to have a seat. We have plenty of seats left. That is not always the occasion. Usually it's packed here. I know it's lunchtime, but you can have a seat here and have a drink. Also, hello and konnichiwa to all our online guests. We are live streaming from the fair, and also all of the talks will be available throughout our homepage. So if you missed a specific topic, you can learn about that online. We'll be talking about something rather specific, and I have the honor to announce a guest that is quite rare, and you will soon learn why. I will announce the title, which is Opportunities for Hydrogen Technologies Through High Voltage Impedance Spectroscopy, also called EIS. And for that, please welcome with me on stage CEO of SIVONIC, Hannes Benecke. Hannes, welcome on stage.
Thank you.
So usually when you have a rather, let me say, technical topic, companies do a little marketing trick. They send, if the unsexier the topic is, the hotter the people on stage, the younger the people on stage. But you are not here to just as a marketing figure. You are the founder of SIVONIC. And I've never seen such a young founder, so I'm kind of curious. What is your position in the company, and what company do you represent?
So I'm the managing director of SIVONIC. We are the experts for high voltage impedance spectroscopy. And today I'm here to talk a little bit more deeper about this theme, because I think that is something everyone as manufacturer for electrolyzers and also fuel cells should recognize this. And that's why, especially when it's a little bit more detailed or it's little bit more specific, I think that it's important that someone does make everyone clear that this is important.
Exactly. And before we do a deep dive on your product, just give us some brief facts about SIVONIC, because it's the first time you're here at the fair. So I think many of you are curious, who is this company and who are the faces behind the company?
Well, we are a company. The name SIVONIC doesn't exist so long yet. So the name SIVONIC and also our product, the ICE meter, exists since a little bit over a year now. So it is quite young. But we are located in Magdeburg, so in the heart of Germany, and we have a team with experience over 20 years now in impedance spectroscopy. So you can also see in our history on our website what we did in the past before, or what our team did before. We worked most of the time as a OEM manufacturer for these things, but we decided to make our own brand, our own name. And that's why also maybe I'm a little bit, the experience of our team is like 20 years, and I was not in the team since the beginning. So, but we decided to put a name on it to create a brand for high voltage impedance spectroscopy right now.
And we need to talk about high voltage impedance spectroscopy. We need to break that down and also understand what does this have to do with hydrogen and fuel cells.
Of course. So first of all, that is the long version of this name is electrochemical impedance spectroscopy. So it's not the easiest name to pronounce. The short form is EIS. So everyone who is in this hydrogen matter knows what's going on with EIS. But there are some changes in the past. The EIS, the measurement principle, is well known since over 20 or 30 years, so that is nothing new. What is new in the thing is that we do this in high voltage levels. Formerly it was to investigate electrodes, for example, materials of electrodes with low voltages and also low currents. and now it's getting bigger and bigger. What you actually do at impedance spectroscopy is that you modulate, for example, a current. You get there are two ways, but I explain one. You modulate a current to a, for example, to a field cell.
Yep.
And because of this modulation current, that is an alternative current, so plus minus again and again, and there is an answer of the field cells in the form of the voltage. So, and you can measure the voltage and also the phase angle, and with these informations you can calculate the impedance. The impedance is something like the internal resistance of the field cell, but it's getting a little bit wider, so it's getting a little bit further. You have many more information what's going on inside the field cell.
See.
So when we're talking about the internal resistance, you just measure that what's already there. The physical internal resistance in ohm, it's a real part. But the impedance is you have a real part and you have also an imaginary part. So the impedance measurement value is a complex value where you have to do, we have both. You have the real part and the imaginary part. And the imaginary part comes because of the structure of the field cell and also the design of the field cell. So it changes from device to device. And when you know the impedance of your field cell, then you can make conclusions about how to optimize some processes, what's going on. You have with an EIS, you have the chance to look inside the field cell and look for example, do you have problems with evacuating the water after the reaction? Do you have problems with for example, just take it with the water, or do you have temperature problems, for example, that you can see with the EIS?
So this is one of the reasons why it is so important to do the measurements. And I want to move on to the benefits of the EIS that and your let's say technology that you brought out, because you just mentioned the keyword high voltage.
Yeah.
Why high voltage?
So, like I said before, that's a well-known thing or a well-known measurement system, but in the past it was only on cell size. You know, you just investigated some cells, maybe a little short stack or some cells together, so the voltage was not really high. And now you are able, with a high voltage IS meter, you are able to measure the impedance of a whole full-size fuel cell stack, or also of a whole full-size electrolyzer stack.
This is, I think, you're probably the only one who can provide that service.
Yeah, well, it's kind of hard, you know. So it's to do. I talked in this fair with many people, and it's kind of hard. And they said they know EIS, they know what to do there. They worked for years in the EIS, somewhere in the laboratory, and they said to do this under high voltages is quite hard. And they say it's glad that this exists right now.
Well, EIS is a proven method, and I can do my measurements on the fuel cell. And do you also do electrolyzers, by the way?
Yes.
Okay, so
yeah, of course. So fuel cells, electrolyzers, and also batteries. But today, in this exhibition, we are the main reason why we are here is because of the fuel cell stacks and also the electrolyzer stack manufacturer.
Exactly, and this is so interesting because, well, I want to first of all, I have more questions, but my main question is, why is it so important, if I can measure the fuel cell, why is it so important to measure the whole stack? What's the difference?
Yeah, when you just investigate a cell, you cannot say if the things that you investigated or the things that happens when you do this on cell area, it's kind of laboratory use. Yeah, you have a laboratory, you have the best environment you can get, it's not the real environment. Yeah, and when you then put all the cells together, you have to be sure that even if you have like 150 or 300 cells together, you have to be sure that the one in the middle works exactly the same way as it does in the laboratory when there was only a single cell. And to do that, you need something which can handle a full-size stack and which can do a measurement with a full-size stack and simultaneously investigate all the single cells.
So it feels like your company on the solution just popped up in the right year and at the right moment, because now we are facing I think one of the key words this year is scalability.
Yeah.
Everyone wants to scale up now, also because
Yeah.
of the political pressure.
Yeah.
Or let's say the industry that is making pressure on the politicians. But so this is perfect timing because we are moving towards large scales. I want to know from you what other key benefits does your method, I think you're not going to reveal the details, but what other key benefits does your product have?
Yeah, for example, when you investigate a full-size stack, you have to be sure that you can measure the whole system under real conditions. For example, when you investigate a fuel cell and you have no load on it, you won't see the changes of the impedance, and you won't see what's going on inside because you don't know how is it running when it's under real conditions, so under load. And we have the opportunity way up more than 2,000 amperes DC to measure the impedance of the fuel cell stack.
Yeah.
So, like I said before, when you have problems with the evaporating of water, for example, you can't see that when you have no load on it. You have to have load, and you have to have high load, and you want to measure the impedance under the conditions, because the impedance itself changes over the load. So you see something, or when you want to have a good picture of what you are building there, then you have to investigate it under different load types and under the point where you want to operate it.
Yeah.
And that's why it's necessary to do this under load. And we can handle high voltages, of course, we can handle full-size stacks, but we also can handle high currents. And then, on top of it, we can modulate high modulation currents. So it's necessary also to create or to measure the impedance of low impedance cells. Is the cells getting bigger and bigger?
Yeah.
You see this here also on the exhibition. They're getting bigger and bigger, and that is the reason, because the impedance sinks. In the future, it will sink more, so the impedance getting in a real tiny condition or in a real tiny area. And then you need something with high power, with high modulation current, and we have this to investigate the impedance of this.
In order to develop a measurement tool that can do measurements on fuel cells, batteries, and electrolyzers, you probably also need fuel cells and electrolyzers. Are you working with a company together, or did you work during the research and development phase with the company together?
Yeah, we have our own R&D department. So everything what we develop is our own development. But of course, we had some good partnerships in the past, and also will have good partnerships in the future. So, but in case, or in fact, everyone who needs impedance measurement is or can ask us.
All right. If you have a question right now, I can come down to you to answer your question.
Yeah, it's a detailed theme. That's why.
Sorry, I'm not. We are not here to explain the basics of a fuel cell. This is nerd talk time. But I'm pretty sure the right customers will come to your booth. And so, just for us to understand, who is your ideal customer?
Well, I'm not sure if I can say who's the ideal customer, but I can say who's the customer. Yeah, the customer is everyone who wants to investigate his stack. So a manufacturer of electrolyzer, a manufacturer of fuel cells, manufacturer of test stand stations, for example, for electrolyzer or fuel cells, but also integrator of systems who wants to do a quality check of their things. When they want to integrate something in a storage, for example, then they can do a quality check, because they have something what helps them in a fast way to investigate the things he get.
Yeah, so interesting.
And so, in case, or almost everyone here on the exhibition who works with cells is a potential customer for us.
Everyone who works with cells, not human cells, but
electrolyzer cells, fuel cells.
What I would like to know from you, as the representative of Savonic, what are the future plans that you can reveal here on stage for the company?
Well, Yeah, I can say that. We want to be the standard for electrical impedance measurement. That's we have a really good device. I would say the best one, and we would go in the future to and help all the electrolyzer manufacturer and also the fuel cell manufacturer to get the best device for their production or for their development.
Great. So if I ring you today and say, hey, for my stack, I need your ice meter, how long does it take until it's delivered to my door?
Yeah, because we have our own production on site, we can handle it in around about 12 weeks, for example. So when you come to us and say, I have this things to do, I have this size, and I want to have this modulation current, for example, then yeah, like 12 to 15 weeks.
So I understand
depends a
that
little
you
bit.
also do some customization
Yes.
for every client. So that
Yes.
also takes, it is included in the
Yes.
12 weeks time that you need to do the proper assessment.
Well, just look around. When you go from booth to booth, you see that there's every cell or any fuel cell or electrolyzer cell looks a little bit different, and so especially also the contact of our system to the stack, and the power of the system is customization because every cell or every stack looks individually, and that's why we also have individually solutions for the customer.
If we have a look at the whole hydrogen and fuel cell industry, and let's call it business at this time, how do you think will the whole industry develop?
You mean the whole hydrogen market? And
Yes.
well, what we see right now is some years ago, a customer said, well, we need a high voltage impedance measurement spectroscopy. So that it wasn't, they weren't sure how is the market going. We know fuel cells and also this fair here is since over 10 years a thing. But we see in the last 2 years so a big acceleration in the whole market. And I think, well, in my opinion, that is not, that's just the beginning, and it will scale up and it will go further. And we see how people ask us to support them with EIS. That sees me, or that shows me that there is a really big interest in the market, and there is a really big interest in this technology, and to make the technology as most as efficient as it could be.
So how did you create your product? Did you look at the market and were like, oh, I see a niche. We have measurements regarding impedance, but not high voltage. Let's develop that. Wish it was there, or was it an invention that just came out of the blue?
You see, when you look on the tests which were done, then you know, okay, everyone is just testing small systems, just testing cells, just testing short stacks, and we want to look on the side from the other way. So we want to look from the other side. So we would say, and sometime that would be a whole stack. So you should be able to measure also a whole stack. And that's why we said, okay, let's focus on the whole stack. Let's focus on the measurement device which can handle this, and which gives you the opportunity to test not just a small part or not just a cell in laboratory conditions, but to do this under real conditions and from big size. And that was our thought when we created the product.
Very impressive. I can only say thank you so much for having you here. What's your impression of this Hydrogen and Fuel Cells Europe Fair?
Well, as you said in the beginning, that was our first time here at the fair. So I know, as a visitor, I know it from the past, but it's nice that an exhibition in this size is getting back again, and it grows. And I see here, when I look, especially in this hall, that the whole market is, there is so much. Well, it is accelerating, and we see this here also at the booth. Had many good discussions with customers, with potential customers, and also with known customers. So I think we will come again.
That is exactly what I want to hear. So thank you so much for having you here. I'm happy to welcome you here next year. It was very interesting to talk to you, and I'm very impressed by the spirit of your company, the heads behind the company, one of the youngest leaders that I had here on stage. So that's really impressive, and your company seems to be very knowledgeable, very professional. It's great to have you here. I can only say that once again. So thank you very much.
Thank you very much. Thank you very much
Benecke.
too. Thank you.